Hi guys, welcome back to another physics video. It's me, your instructor, Akshata, and today we'll continue our focus on projectile motion. We'll dive into specific problems and strategies on how you can approach these problems. If you recall, we covered projectile motion last time, but this video is mainly just an extension and a more in-depth focus on just the problem solving. So before we get started, here's just a quick recap. Projectile motion involves motion in 2 or more dimensions. And don't worry, we'll only be focusing on x and y directional motion, so 2 dimensions. Also, these are independent of one another, but there is x and y movement happening at the same time. And I know it sometimes gets confusing, but we'll try to calculate x and y separately. So once again, here is our list of equations. These are incredibly important in the whole problem-solving process, so I would advise that you guys get really comfortable with whatever goes in these equations. So here is a really helpful list of strategies that you guys can use when approaching a projectile motion problem. So first, you want to read the problem and underline key details, like give you a velocity or acceleration, make sure you note those down. And also take into account the x and y directions and separate them. We can also solve for components. Make a knowns and unknowns list using the information from the prompt. And now you should use your list to decide on 2 or more equations. You may need to go through several steps before you reach your desired answer. So after that, you should solve for desired variables. Or another step in your process could be writing unknown variables in terms of the variables that you already know. This will really simplify the process. Why don't we start with an example? You kick a football from the ground at a speed of 10 meters per second at an angle 30 degrees from the horizontal. So we can see that this question has 2 parts. So the first is how high does the football rise? And the second is how far does it hit the ground? So I know what you might be thinking. This question barely gave us any information and then it's asking us so many questions. So I would advise that we go through our strategy list and let's see what we can do. So first we should read the problem and underline our key details. So we know that the football was kicked from the ground at 10 meters per second. So our velocity will be 10 meters per second. And they also gave us the angle, so theta would be 30 degrees. It always helps to draw a little diagram or something like that just on the corner of your page. After we've pointed out the key details, it's time for us to separate the x and y directions. What I mean by that is we have to keep track of how it's moving in the x direction and the y direction at the same time. So this can be like the possible path for our football. So as you can see, it's gonna go up and then down. And that's all y direction motion. And in the x direction, it just keeps going to the right. Also, it's important to notice, and I mentioned this before, that the y direction experiences an acceleration of gravity, which is 9.81 meters per second squared downwards, while the x direction has no acceleration. And now it's time to make our knowns and unknowns list. We are given our velocity of 10 meters per second and our acceleration of 9.8, which is g. And we're also given our theta, 30 degrees. Our unknowns are how high the football rises in this trajectory, so h max, and how far it hits the ground. But we'll just focus on the first one right now. Before we start solving this problem though, I want you to note that we have a hidden zero. That will really help us out when solving. So when it asks how high the football rises in its trajectory, what is the ball doing at the top of its flight? The top of its flight is its maximum height, and based on our previous videos, we can see that the ball is actually stationary, just temporarily not moving in the y direction at the top of its motion. So its Vy is actually 0. I mean, it makes sense if you think about it. Whenever you throw a tennis ball in the air, it stops for a second, right? So and it always stops at the top of its path. So whenever a ball reaches its maximum height, it's always at rest. Now we're ready to choose an equation. So what looks like the best equation to solve for here? We have to find the height. We're given the initial velocity in the y direction and the final velocity, as well as the acceleration. So it seems like our best bet would be equation 4. Because we're solving our equation in terms of the y velocity, we need to begin by taking a component of the initial velocity. If you remember, the problem said that the ball was thrown at a speed of 10 meters per second with an angle of 30 degrees to the horizontal. What we want to find is the y component of this velocity, because that is what we're using to solve. So we can just use trigonometric equations to solve for this Vy. Sine of 30 degrees is equal to Vy over 10. So Vy is 10 sine 30 degrees. So by calculating, we see that Vy is equal to 5 meters per second. Now that we found the y component of the velocity, we can use that in our equation. Our final velocity Vy is 0. Our initial velocity component is just what we found earlier, 5 meters per second. And then we can sub everything into our equation to solve for h. By using a calculator, we see that h equals 1.275 meters. Now on to the second part of our problem, which asks how far the ball hits the ground. Basically, it's asking for the total x direction the ball travels. Judging by our list, there isn't one equation that we can use to directly solve for the x, because both of these equations involve something that we don't know, which is time. So our best bet would be to solve for the time using variables that we do know. And then we can use this time variable to solve for the x. So it's just 2 steps. So for the first part, solving for the time variable, this equation looks the best because we do know our v and we can find our v initial. And then we should use this equation to solve for our total displacement in the x direction. Let's begin by solving for the time the ball spends in the air. So we know that our v final in the y direction is 0 meters per second. And we know this because the midpoint of its trajectory, the ball has no y velocity. Solving for time, we see that time is Vy minus v initial in the y direction all over g. And then substituting in these values, we see that the time is 0 minus our y component of the velocity all over negative 9.8. Our t variable becomes 0.51 seconds. But there is a trick here. We've only calculated how far our ball travels halfway. We need to actually multiply this quantity by 2 because we want to find the entire time it takes to hit the ground. So our total time would be 1.02 seconds. Now that we know the total time it spends in the air, we can use this to solve for our x displacement. So make sure that this equation is entirely in the x direction. So we want to convert everything. So x would equal v0 xt. And since there's no acceleration in the x direction, this is our final equation. But there is still one more step. We have to solve for the x direction velocity. So just like we did for the y direction, we need to find it in the x. Cosine theta is equal to Vx over 10 meters per second. So Vx is equal to 10 times cosine 30 degrees. And then we can just substitute this value along with our time variable into our equation to get the x displacement. We end up with x being 8.83 meters. So that's all I have for this video. Thank you so much for watching. If you like this video, please hit like and subscribe to our channel. Also, turn on that notification bell for future videos. If you have any questions or suggestions, please email info@karmantlearning.org.